Alright, so let me ask around then. I heard a lot of people got. Sophia, what letter tells you what letter is the same as slope and rate of change? It says what letter equals M. So when we talk about rate of change or slope, we call it M. And what goes on the top of the slope formula, Aiden? You subtract the y values. We did it with word problems. And then what goes on the bottom, Lauren? Yep, y is on top, x is on bottom, and that'll tell you your rate of change in really any type of data. In a table, in a graph. Over here, I just have points. You can't see it all yet. You can logically come up with slope and rate of change, and you can look at it, think about it, and get it. But this formula will also lead you there every time. So, number 2. They should all come out the same numbers. So for the table, we could call this the first point, this the second point, this the third point, and this the fourth point, right? So I can do slope formula really with any of those, but I think for consistency purposes, I would say that -4, 1, I'm going to call that x1 and y1. And then -2, 4, I'm going to call that x2 and y2. But I want to be honest in that I could have done this as 1 and this is 2. Or this is 1. I could have even found the rate of change between this one and this one, and it'll come out the same. Okay. Can you tell me the numerator, what I'm subtracting? Go ahead, Jake.
Well, I used the bottom two, so I had 10 minus 7.
Well, I'm going to continue with these
those,
two.
Okay. So 4 minus 1 over -2 minus -4.
This is the rate of change we're looking for, 3 over 2.
Isn't it 1.5?
No, let's not call it 1.5. Let's leave it in fraction form. I know I'm going back and forth a lot between fractions and decimals here. Fractions best. Number 3. Let's do 2 points in that graph. Any 2 points. Let me have a question on number 2 first. Okay, Zach, tell me a point in the graph here. So we'll use -1, 0 as x1, y1. And tell me another point, Alicia. Oh my gosh, what kind of points did those two pick out? They picked out intercept. How lovely. Okay, we'll call on somebody else. Who wants to be called on? So many people. Gabriel, can you do slope formula with these specific 2 points? Okay. Yep. All right, so I want to highlight. So he did y1 minus y2 and x1 minus x2. Honestly, as long as you line them up, it's going to come out correct. So that's fine. He'll get the same answer as if I put y2 first. So I'll do both. So this would give me -3 over -1, which is 3. And this would give me 3 over 1, which is 3. It comes out the same. All right, 3. How can I see 3 when I look at the graph? Who can look at the graph and see that the rate of change is 3? Like we did the math here, the subtraction, the formula, but how do you visually see that?
Because it goes that 3 across 1, that 3 across 1.
Right. So going back to slope and rate of change, when I see how these points change, they're 3 away. So it's up 3 over 1, up 3 over 1. The y is changing by 3, and the x is changing by 1. So that's like this. The y changed by 3, and the x changed by 1. I can see it in the picture. All right, last one, number 4. I got -1/2. All right, let's go over homework from Thursday. All right, let's look at this. Direct variation. We're gonna make this into just a baby brochure. So start with this fold, and then do another 1/3 fold. If you look at this part, it's helpful. You want to fold this one in so it's covering the part that says graph. You know, fold it 1/3 in. And then fold this one in. Just, this is all I want to see on the inside. This one here I added in. So this little tiny print doesn't really make sense with the brochure, but I don't like white space, so I put some problems there.
Too much on this side.
I was gonna keep that. Like a little pencil wedge. Alright, so direct variation. This is chapter 3-4. Direct variation. This is direct variation. It's chapter 3-4 in your textbook. If you want to read about it, I recommend it. It's an equation that starts at 0 and then moves with a constant rate of change. You'll be very familiar with these. It shouldn't seem like anything brand new. We'll look at in this foldable, in this section of your textbook, in this topic, in the curriculum, we'll look at direct variation in 3 ways. We're going to look at tables, which we've done already. We're going to look at graphs, which we've done already. And we're going to look at equations. which we've done the least amount, I'd say. So when you open this foldable, you'll see tables first, and then graphs, and then equations. So this is really more of a reference. This is more of a reference sheet than a practice sheet. This is for you to refer to and look at when you're asked questions about graph variation. Maybe I'll go ahead and tell you right now what the equation looks like. Here's what the equation looks like. It's y equals, there's a y and an x. The y and the x stay y and x. And the k is the rate of change. Also known, what's another word for rate of change? Slope. So the slope or the rate of change goes right there with x. So your equation always has y and x in it. And you put the rate of change right there with the x. Did you guys write that down? Or do you just know it? You wrote it down there? You wrote it down? All right, let's head to the table. Function table. Alright, look at this. Look at this function table. We got cookies. How much does a cookie cost? 20 cents. So how much does 2 cookies cost? 40 cents. And how much does 5 cookies cost? $1. Do you guys get 5 cookies for $1 anywhere in your life? No. Those are baby cookies. The input, the x values, are the independent variables. So if you're ever asked about independent versus dependent variables in math class, I know you talk about it a lot in science. X values are independent. They're input and independent. Those IN prefixes kind of go together. The output or the Y values are the dependent variables. Very sciencey standard. Your price depends on how many cookies you buy. I think we did that in the beginning of the year. So you guys, you know from what we covered Thursday that you can see the rate of change here. It's going up 0.2, up 0.2 for every cookie. All right, the graph. The graph that represents direct variation has 2 characteristics. The first is that it's linear. It's a straight line, and it passes through the origin. Any straight line that passes through the origin is called direct variation. It's like vocabulary. That's what mathematicians have decided to say about it. And it's because it's like a really constant, reliable rate of change. It's easy to see. So you can do slope formula to find rate of change, or you can just count. This goes up 20 cents for every cookie. You can count the distance between points, and that'll tell you the rate of change. That's what this is. No, it doesn't. You can represent direct variation equation that contains 3 parts. So this is the equation. Y equals K times X. I've already told you to write it down. For the cookie situation, you would put 0.2 right there. So now in your groups, I got a little challenge for you. No, is there room on the back? Yes, yes. Put this in the middle. Put this in the middle.
This is all still for my work?
No, your notes on that.
Oh,
Alright, so you're gonna think of a word problem. Similar to this cookie one, but not exactly the same. In your groups, you're gonna start with the table or the equation, whatever's easiest. So you're gonna make a table. Maybe it's purchasing something, maybe it's selling something, maybe it's a growth rate. You can also use any other examples in your notes. Find the rate of change in your table, make sure it's constant. Make a graph and an equation. Tyler, do you want to come work up here? We have an opening. Watch out for the computer when you walk by. I got gas. This is gallons of gas, and this is how much it costs. So I'm checking it by seeing is the rate of change constant. I see that it's $2 for a gallon of gas. I see that they put the 2 right in the K spot for the equation. And then when I look at their data, I'd love to see an X and a Y, but it was right through the origin up to over 1. And so this was the team who got it done quickest. All 3 people.
can you do like next week? Actually, no one's going to because I'm able. Like, so look at that. What do you sound? Yeah, basically. Oh. I'm going to finish.
I know, but like that one, I don't know how to do it. No, but
Yes, Tony.
It's 126. How much?
Yeah, what a trip this is.
You're right. Oh, but it's not real sure. I'm gonna be looking for it Thursday. I'm taking points out if you lose it. Alright. Really quick. Let me do number 5 with you.
Come on.
Yes.
Oh, okay.
Now there is 2 examples for you.
I think you have extras. I had a B last Hey.
I know. What's the point? I can write you a house if you think about it. There it is. Is that it? I have to run.